as other laboratories are, my lab is also not just a place, but more so it's a collection of people, their inquiry, their discoveries, their accomplishments. That's why I've really had a number of great graduate students over the years and undergraduates that have been really a lot of fun to work with. The name of our lab is Wetland and Aquatic Biogeochemistry Lab. The students came up with that because they liked the acronym WABBLE, which was kind of a fun acronym. But what is wetland and aquatic biogeochemistry? I get this question a lot. So we study how chemistry basically flows through these systems, and we characterize the physical environments that control how the rates at which they go and the direction. So the figure on the bottom here is really showing that most of the resources in an ecosystem are either wrapped up in organic matter or in minerals and are not available. So we study these regulators that then make those nutrients available to the biosphere. And conversely, we also look at processes that take the available nutrients and shunt them back into the non-available pool. So here's a couple different food webs, and people always say, well, where are you on the food web? Well, at the bottom of both of these diagrams, one's an oceanic and one's an estuarine food web, you can see the primary producers. And sometimes people put the sun there, that's the energy that the primary producers use, and then everything flows up to the food web. Well, if they're the base of the food web, then we're the foundation of which the food web is sitting on, because the biogeochemistry and the sediments in the soils and the water column really control how that energy flows up through those systems. I just wanted to talk about two or three quick projects here to have an idea of how we apply this. If you were seeing Errol's defense about a month ago, one of the projects he was working on, we're spending billions of dollars in Louisiana to build these created marshes where we have open water on the left panel there, and we fill them either with sand or mud. And then we're interested to see, well, the functions of those wetlands, how long does it take them to come back? And Errol measured a whole bunch of things here for carbon sequestration and nutrients to the food web, and came up with about an average of about 18 years. So it's going to take some time to get these systems back. Jacob Chang is one of our undergraduate CES students doing research in our lab, and he was using the same site, but really looking at how these marshes will do at removing the nitrate that's going to come flooding in when the river diversions are turned on. And I'm not going to, he sounds some pretty exciting stuff, but I'm not going to steal his thunder here. He's presenting at Discovery Day this afternoon, and I encourage everybody to log in and see that. And finally, we've got a couple NSF projects looking at carbon loss in the coastal wetlands. Everyone's very familiar with our loss of coastal land. And Yadav Sukata has been working on his PhD now for 3.5 years, published a number of papers really looking at the fate of that organic matter. We've got 1.5 meters up to 1,000 years of organic matter that's basically being eroded and decomposing into carbon dioxide pretty quickly. And that's a collaboration with George Shua, Rob Cook from chemistry, and Lisa Chambers from UCF. And finally, sort of related to this project, because 2020 was sort of the year of the COVID, but it was also the year of the hurricane here in coastal Louisiana. And we were out there measuring the erosion rate. So what we noticed was that the long-term erosion rate at 0.35 centimeters of edge lost every day, that's substantial enough. But the hurricanes that didn't impact Barataria, but were nearby, and there's a lot of them you can see in that diagram there to the left, they increased the erosion rate more than 60 times from the time that their wind field was associated with the bay. So really, while people focus on direct impacts from hurricanes, these indirect impacts, as more and more hurricanes are projected for the future, really may cause more and more of that carbon to be liberated and go back to the back into the environment, into the atmosphere.